ever heard of quantum physics? If so, for sure, you've come away with more than one headache, and I don't blame you. Quantum physics is one of the most interesting branches of science, but also very difficult to understand, with its theories of dead and alive cats at the same time, or even parallel universes. Ready to go crazy and understand the convoluted secrets of quantum science? Or not? Stay tuned and watch. But immediately after the opening theme, which we finally have for you, So my old sports, this is EdDevelop, where you will find the best scientific and similar curiosities. Subscribe and activate the notification bell to enrich your day every time we upload a new video, and consider our Patreon. Find the link below in the description. Let's get into it. The smallest world. Have you ever wondered if there's a world beyond what we can see? A world that is right in front of our eyes, and yet we don't understand it. Welcome to the quantum world, the smallest world that exists. And when we say small, we mean very, very small. Next to the protagonists of the quantum world, the smallest of all ants looks like a gigantic monster like Godzilla. Quantum physics is the science that studies how the subatomic world works. Don't worry, we won't start with difficult concepts. It's as simple as understanding that everything in the universe, from you, my good old sport, to a grain of salt, is made up of tiny building blocks called atoms. Atoms are made up of even smaller building blocks called neutrons, protons, and electrons. But it doesn't end there, because the protons and neutrons at the center of an atom are made up of even smaller building blocks called quarks. Quantum physics simply studies how these little blocks, which it calls elementary particles, work. Why is quantum physics important? Conventional physics, based on the laws of Maxwell, Newton, and Einstein, is easy to understand and is what we use to measure the world of big things, from a coffee bean to a car. We all know the normal laws of physics. If you drop something in the air, it will fall to the ground. If you throw a ball, you can easily predict where it will end up. But what about quantum? Do things work the same way in the world of tiny things? Well, get ready, because this is where we're going to blow your mind. In two places at once? Okay, my old sports, sit back, relax, and get ready not to fry your brain. Next up is the double-slit experiment. Imagine throwing a ball at a wall with two vertical slits in it. What do you think would happen? Well, logically, it would either go through one of those slits, or it would hit the wall and not go through to the other side. That's how it works in the world of big things. But it's not the same in the quantum world of tiny things. This experiment was done by shining light into a wall, but by placing a piece of cardboard with two slits in the middle to study how light gets through to the other end. What they found was incredible. Before this experiment, physicists divided the world of the smallest into particles and waves, and could not agree on whether light was composed of waves or particles. Waves are disturbances, like the waves in the water of a swimming pool. Particles, on the other hand, are the small blocks of things, like the ball we just mentioned. But here, it gets complicated. The double-slit experiment surprised us by showing us that the light arriving at the other end was not made up of two slits, but of several slits of light, demonstrating that light behaves as waves that reinforce each other in some parts and cancel each other out in others. The strange thing is that when the experiment is performed by throwing particles of light, that is, small blocks of light, through the slits, the same result is obtained, even if you throw them one by one. It is as if the particles that we have already thrown in the past are interfering with the particles that you are throwing in the present and in the future. Is your brain getting warmer? Well, there's more, because if you were to do the same experiment, but put a photon detector on the slits to find out which of the two slits the light is going through, you would end up only seeing two slits. Scientists discovered that when it comes to the subatomic world, the little blocks of the universe are not only particles and waves at the same time, but also the result can change as soon as you measure them and find out where they have been, as if they were in many places at once, until you pay attention to them. Hey, wait! Now's the time! Subscribe to the channel to be entertained while learning. It's free! This is called wave-particle duality, the Hamlet effect. What could theater have to do with the physics of tiny things? It seems impossible, doesn't it? But if there's one thing quantum mechanics is all about, it's making us think a lot. No one can imagine atoms pondering the questions of life, but to be or not to be seems to affect particles that, incredibly, become indecisive until someone tells them which position to take. Confused? Relax. We'll try to simplify. The Hamlet effect, also called Hamlet's principle of indeterminacy, says that you cannot know know the position of a particle or its level of motion at the same time, and that particles can be in multiple places or states at the same time. A radioactive atom can be simultaneously radioactive or non-radioactive until it is not measured, and at that moment it is defined as radioactive or non-radioactive. To understand this better, let us explore the most famous mental puzzle of this science: Schrödinger's cat. Imagine you have a box, a cat, an undecided atom like the one above, which has a 50% chance of being radioactive and non-radioactive, a poison capable of killing the cat, and a mechanism that will detect when the atom is defined and, depending on this, will activate the poison mechanism. If the atom becomes radioactive, the poison is activated and the cat dies. Otherwise, the cat lives. What would happen if you locked the cat inside this box and no one saw the atom? This is where it gets even crazier, because if nobody observes this undecided atom, it will obviously be in both states, radioactive and non-radioactive, at the same time. Therefore, the cat is also in both states, alive and dead at the same time, at least until the moment when someone opens the box and confirms what has been the fate of the feline. At that moment, everything is defined, and the cat is either completely dead or completely alive. Do you get it, old sport? Let's hope not, because if you did, it means that we haven't explained it in the right way. After all, this is the same as the famous quote by the American physicist Richard Feynman: "If someone thinks he has understood quantum mechanics, then he has not understood it." Haven't you gone mad yet, my old sport? Well, don't worry. Hopefully you'll get it in the next point: quantum entanglement. And you'll say, but what the hell is quantum entanglement? Let's say it's the most romantic and sensitive theory of quantum physics. Although, of course, it has nothing to do with atoms sharing flowers, chocolates, or subatomic poems. This theory makes many theoretical physicists of this interesting science think about the existence of parallel worlds. It turns out that these undecided particles that want to be more than one thing at a time are often connected to other particles as undecided as they are, with their soulmates, two atoms that are positive and negative at the same time. It's like having an iron ball frozen and red hot at the same time. What is entanglement? Well, again, these particles are defined when you measure them or locate them. It's like saying, you got me, I'm going to be positive once and for all, but stop entanglement. The funny thing is, if this particle is entangled with another particle, once you define the first, the other one takes the opposite position. Confused? It's as simple as this. As soon as an atom is forced to be 100% positive, its pair is forced to be 100% negative, as if to maintain the equilibrium of the universe. Remember the cat from the previous experiment? Well, the best is yet to come. Both the cat and the atom are in two states at the same time, alive and dead. Then someone opens the box and we discover that the cat is alive and kicking. What if, in another universe, there was an atom that was intertwined with this one that took the position when someone opened the box? Would that mean that there is another universe in which the cat died? So, was the cat in both universes at the same time? Quantum physics is one of the most interesting, amazing, and complex theories of our time, but it doesn't stop there, because its applications and uses are truly endless. From helping us to create the most powerful and fastest computers in history, to protecting people's information, to revolutionizing the world's technology and energy industries. Plus, of course, giving us a good brain jolt every now and then. That's all for today, my old sports. Don't forget to hit like and share, and we'll see you in the next video.